This is section 3.4, number 18. So the problem asks us to solve the equation over the interval 0 to 2 pi. And here's the problem. Cosine 2x is equal to 1/2. So given that we have 2x in the input of the cosine, we know that cosine of 2x is equal to 1/2. Well, there's two angles between 0 and 2 pi that would give us that the cosine of that angle would give us 1/2, and that the first one is pi over 3, and the second one is 5 pi over 3. But we also know, in addition to those two angles, that if we take any multiples of them, any multiples of 2 pi, it would also give us a solution as well. Okay, now we want to solve this problem now. We don't want to solve for 2x, we want to solve for x. So the way we do that is we multiply both sides by 1/2, which is the reciprocal of 2. Is the reciprocal of 2. So we do that as well on this equation. Okay, on the left side, I get x. On the right side, I have to distribute that 1/2. So if I distribute that 1/2, I get pi over 6 plus pi n, because that 1/2 and that 2 basically becomes a 1. On this equation, so on the left side right here, we get the 1/2 times the 2 gives us x. On the right side, I distribute that 1/2, so I get 1/2 times 5 pi over 3 gives me 5 pi over 6, plus 1/2 times 2, those are reciprocal, so that gives me 1, so what I'm left with is pi n. Okay, now these would give you all of the solutions, but we don't want all the solutions. We're restricted to just the solutions between 0 and 2 pi. So if you remember from class, that's basically we want to test out values of n to see which of these x's fall between 0 and 2 pi. So let's look at when n is equal to 0, we get that x is equal to pi over 6. So these right here are the solutions. So pi over 6 works because pi over 6 is between 0 and 2 pi. So we know that works. So let's test when n is equal to 1. So when n is equal to 1, we get pi over 6 plus pi. Well, that's equal to 7 pi over 6. 7 pi over 6, is that between 0 and 2 pi? Well, yeah, it is, right? So the next n that we want to test out is 2. So when n is 2, we have pi over 6 plus 2 pi. But we already have 2 pi here, and if we add a positive quantity, we know that we're going to be out of that range, 0 and 2 pi. So we know we can stop at just when x is equal to 1. Likewise, we can do the same over here. So n is equal to 0. When n is equal to 0, we get 5 pi over 6 plus 0, which is just 5 pi over 6. And when n is equal to 1, we get 5 pi over 6 plus pi, which is 11 pi over 6. That right there was just a mistake. So these are all of our solutions for this problem.